Alright, this is part 2 of lecture 4. We were talking about electron configuration. And just as a reminder, we have the arrangement of electrons of an atom is distributed among shells 1 through 7. Those shells contain subshells. Okay, and we designate those subshells or sublevels as S, P, D, and F. And each of those subshells contain orbitals, 1 for S, 3 for P, 5 for D, and 7 for F. And of course the electrons, and this is the maximum number of electrons that can exist in those orbitals of those subshells, is 2, 6, 10, and 14. Now, if we wanted to lay out the electron configuration of a particular element, then we have to show a certain pattern because the energy required for electrons to exist in these shells and subshells is different, but it is predictable. And so this is how we can predict the configuration. We begin with the lowest energy level that can exist for an element. Put energy down here. Is the shell 1 and the subshell S. Alright, and remember we have how many orbitals? 1, put that in parentheses, and how many electrons can exist in that orbital? 2. Okay, so as we add electrons to these atoms in this diagram here, we have to add them according to their energy. So the next lowest energy level is 2. Obviously, the lowest subshell is S again, with 1 orbital and 2 electrons. After that, we're still on the second level. We can occupy subshell P. Remember, it has 3 orbitals and therefore a maximum of 6 electrons. Okay, and as we continue a higher and higher energy level, we have 3s, again 1 orbital, 2 electrons, 3p, alright, 3 orbitals, 6 electrons, and the next level, or lowest level that can be occupied, is 4s, again with 1 orbital and 2 electrons. Notice we didn't go SPD because D's energy level requires higher, the level is higher than S, 4s. So 3D is higher than 4s. So 4s is occupied by the electrons before 3D. Okay, which has again 5 orbitals, 10 electrons. The next is 4p, and I'll leave off the orbitals since we know P has 3 orbitals. I'll just put the electrons. And not 4 4d, but 5s with 2 electrons. It's lower than 4d with its 10 electrons, but 4d is lower than 5p with 6 electrons. 6s is next with 2 electrons. Alright, so you would think, based on our pattern here, that the next level to be occupied would be 5d. But actually 5d has a higher energy requirement than 4f. How many electrons in that orbital? We have 7 orbitals, 14 electrons. So 4f is after 6s. Okay, so yeah, scratched out p. 6s. 4f is next. Then we go to 5d with 10. 6p now with 6. And 7s with 2. So 7s is lower than 5f, 14, which is lower than the 6d with 10. Okay, and so this covers from 1 levels from shells 1 through 7 and subshells S, P, D, and F. Now they do go higher, and there are energy levels that are much higher as a result of bond energies. As atoms form chemical bonds, the electrons can jump up into higher energy levels, 7. But this is the ground state or ground level for all of the electrons up through 7s, and you will need to know this in order to answer questions like how many, or what is the electron configuration for an element that has 53 electrons. Okay, so let's see, what element, go to the periodic table, has 53 electrons. Of course, you know I'm going to tell you, but I'll give you time to look. Alright, that element is iodine. Alright, you looked at your periodic table. Let's see, do I have one here? Yeah, I have one. Okay. Iodine is one of the 7A groups, the halogens, and its atomic number is 53. Its atomic weight is 126.90. And this is quite a large number of electrons. How are they configured around this element? Well, what do we have to do? We have to count the number of electrons based on their pattern and write the configuration until we get to 53. And I'll do that right quickly. We have 1s2, that's 2 electrons, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, and 5p5. Alright, so if we went back and added these up, that's 15, that's 17, 6 here is 23, 33, 35, that's a 6 there, that's 41, 43, taking a big risk, I hope I get that right, 49, 51, and 53. Alright, so we have 53 electrons represented in this configuration. And one note that we will cover later is that notice that you have 5p, only 5 electrons. What is the maximum number? 6, correct? So if we have only 5 electrons, we have to remember that there are 3 orbitals, and each orbital has to have one, losing my light here, there we go, each orbital has to have one electron before it can have the second electron. Okay, so obviously with 6 maximum number of electrons, they occupy the orbitals, only 2 in each room, or 2 in each orbital. And so we could write that in this way. This is the first 2, 4, and 6. Now I would write another one, but we only have 5 electrons. So 2, 4, 6, and that's how we would configure it. However, I actually did not write it correctly. I should have written it this way. 5p, 1, 2, 3, 4, and 5, showing that we occupy each orbital with an electron, and then we come back and occupy each orbital with an electron until it's full. But we don't have a total of 6, we have only 5. And we'll talk a little bit about this a little later. We're going to work on isotopes next, and just want to wish you luck on your exam. You probably haven't even watched this before the exam because you know it's not on the test. So we'll come back to this and continue on in preparation for our next quiz and exam.